Hello, my name is Catherine Holmock. I'm the president of Student Senate, and I am here today with Jon Owejan, who is an assistant professor in the Mechanical and Electrical Engineering Technology Department. Hello, Jon. Can you tell us a little bit about yourself?
Sure. I started here about 3 years ago, and I have been teaching courses in mainly the mechanical department, and I've also taken over the curriculum coordinator position for our engineering science 2-year transfer program.
I see you have your bachelor's, master's, and PhD. What are they in?
They're all in mechanical engineering. I got my bachelor's and my master's from Rochester Institute of Technology, and then my doctorate from University of Tennessee.
Can you talk about the professional experience you've had in your field?
Yeah, it's pretty wide. I did my internships starting at my sophomore year in undergraduate, and I was really fortunate. I got into NASA's program. They call it their co-op program, and I went to Johnson Space Center, and I worked with really bright people in different areas of what they do at Johnson Space Center. So I had the opportunity to work in structural analysis of shuttle and space station components. And then the next time I went down there, I worked in their neutral buoyancy lab, developing space tools for extravehicular activity. And then finally I went back and I worked on Robonaut, which has kind of paid dividends for me because Robonaut is a very popular PR tool for NASA. And I was actually involved in working in making the hands articulate like a human's hands. When I finished my bachelor's degree after NASA, I went into a test engineering position while I did my master's degree. And that test engineering position was at General Motors, where they were developing fuel cell technology for vehicles, hydrogen cars. And as I did my master's degree, kind of working full time, I also developed a thesis project with General Motors. And in executing that thesis project, it was the focus of it was a new way to image water inside of a fuel cell. The water that accumulates in the fuel cells is it's one of the major inhibitors of the performance. So it wasn't really a good way for engineers to diagnose how that was happening, and we used neutron imaging, sort of the way X-rays work for if you break your bones. We used neutron imaging for looking at water in fuel cells, and that turned into a career at General Motors for me after I finished my master's. In the course of that career, I worked on several things, a lot of design-related and diagnostic-related activities, all towards developing more efficient fuel cell systems. I was also involved a lot with universities where we needed research expertise. I filled some of the gaps between getting information into General Motors and what the experts at different universities were doing. And it was really there that kind of planted the seed for me it was clear to me, I should say, that I enjoyed working with the students, and I like the atmosphere of where it's opportunities wide open at universities, and kind of people have they can really follow their passion. And I thought, well, at some point in my career, I'd like to go into teaching and be part of that, culture of learning and research. So I decided at that point is when I went to get my PhD at Tennessee, and that would sort of enable me to transition into a path of academics.
So what brought you to Alfred State in particular?
When I was searching for an academic position, I was looking for a school that had a focus on teaching and applied learning. So it's very clear that that's what Alfred State does. And I met the faculty and the students. The culture was there for kind of the interaction between a professor and a student that was more, I would say, casual. So. And it was a way that I thought that I could relate directly to the students and try to get them excited about linking the stuff that we had to do in class to practical examples. That's how I learned engineering best, and I thought that if I was going to be successful teaching in engineering, that I would have to be able to do the same, and I could actually be part of the evolution of engineering education, because that's where a lot of people are going to, is hands-on, applied learning. One of the things I enjoy most is the project-based learning is flexible. So if I see a student that is really motivated to work on a project, that I can immerse myself in the project with that student or group of students usually. And that's a lot of fun for me. That's kind of the dream job for most engineers. And then in terms of lecturing, because everything we do in the lab has a component of introducing the theory. Like I said earlier, I really do enjoy being able to take a theory and then put it into a practical problem. That was, again, where things clicked for me when I was in school, and I think I'm getting better at finding ways to make it click for students. And when you see a student take a solid grasp of a concept and then come back to you and talk about a project that they want to apply that concept that they just learned to in an intelligent way, it's really rewarding. And it's kind of hard to find that feeling in other careers.